Okay, here's 6-2, day 1. And we find ourselves with another probability distribution. This one, the outcomes are how many credits students are taking at El Dorado Community College. It's right around early decision time, so, this one's on your list. Make sure to get your app into El Dorado Community College. May not be on your list. That's okay. No big deal. But you'll see later on in this problem, it's affordable. It's crazy affordable. But we're not getting into that yet. So far what we have is just how many credits students are taking, and then the frequency of students that are taking that many credits. So real quick, let's get a mean and a standard deviation. Again, I'm going to kind of show you the work. Not really. Remember that list 1 and list 2, and then go into stat calc would be the way to do it. That's the way you should. Because I'm not even going to write all these out. After 14 times 0.05 dot dot dot, didn't leave enough room. It's like 14.65. Sigma, I'm just going to write out 2 of them. First outcome is 12. Take away 14.65 squared. Times 0.25. And I'm good for one more here. Should always draw at least 2 of them. That would obviously continue, and it's about 2.06. So on average, students at El Dorado Community College are taking about 14.6 credits, and on average, the amount of credits taken vary from the mean by about 2 credits. Nothing new on that slide. Nothing new. What is going to be new in 6.2 is we're going to start to do some stuff. Like we're going to recalculate the mean and standard deviation, but we're going to transform the data. Now, you might remember back in Chapter 2 we did this. And it should kind of feel the same. Okay? Now, I told you El Dorado is affordable. $100 a credit. Okay, so now I have the same outcomes, but I'm going through and I'm multiplying each one of those by, well, never mind. It's not just affordable, it's really affordable. $50 a credit. Okay, so up in this first spot right here, this is going to be your tuition charge. That'll be $600, right? And that number is coming from 14 times 50. No, excuse me, 12. 12 times 50. Okay, those students are taking 12 credits. 13 times 50. So 10% of students are paying $650. 700. 750. All the way up to our students that are taking a full load of 18 credits, their tuition fee is $900. Okay? Now, one way to go check this out to get a mean. And the standard deviation is you could go back to list 1 and list 2, and you could change list 1. Okay? It's not actually a bad idea to do if you kind of want to, take a guess and kind of experiment with what the new numbers are going to be. Okay? Essentially what's going on is we've multiplied by a constant, and again, in Chapter 2 we saw this before, that if you go back to the mean that you had previously, and you multiply that by your constant, that's going to be your new mean. But now the units have changed because it's in dollars. Okay? We basically transform the data. Now, I'd encourage you, if you have a calculator handy and you're confident with the lists, go put the numbers in list 1 and list 2 and go check and verify. That's if you change all the credits to this, these tuition amounts, that's the mean and the standard deviation that you'll get. Okay? Both are the credit amounts just multiplied by 50. So again, this is not brand new, right? But the big thing with multiplication, anytime you do it to a distribution, it will affect any measure of center. It will affect any measure of spread. Okay, that's huge with multiplication. A little note down here. If you found yourself working with the variance, you could do that too. You could. The thing there, remember, this is always worth a reminder. Variance is your standard deviation squared. Okay, so if you wanted to transform your variance, if that's the measurement you had, one, you could take the square root and get to the standard deviation, then just multiply by b. Or you could just multiply the variance by b squared to get your new variance. It'll work out the same either way. Oh, wait a minute. El Dorado couldn't have been as good as it sounds. There's fees. Oh, but they're not terrible. It's $100 a semester. Okay. These numbers are fabricated a little bit, so we had smaller numbers that were a little bit more manageable. Okay. So now what has to happen is each of these numbers that we had from the tuition, we need to tag on $100 for their fees. Which it technically gives us a new distribution. The term we like to use is that it's transformed. Okay, we've transformed the data. This time, though, it has been from adding. Okay, to go from credits to tuition, we multiplied by 50. To go from tuition to cost, we added 100. Okay. Now again, if you have the data in a calculator with you, I would change list 1. And actually, before I do that, I would make a guess. Because again, what's going to happen? We actually covered it in Chapter 2. You've seen what's going to happen. See if you could guess it and then see it from your calculator. If you want to do that, you'd want to pause right now. Here's what happens. We had our previous mean of 732.5. We added 100. So for this new distribution of total cost, that would go up 100. Sigma is the interesting one. You will see no change. Okay? If you're adding a constant to a distribution, remember, it just moves all the data points together and they don't get more spread out. So sigma did not change. Right? This is the one to highlight right here. It's the toughest one to remember. All the other cases, the data does what you think it would do. Okay? It really does. Except adding doesn't affect spread. And here is just a summary. Put it all together in one slide. For measure of center, if you're multiplying, multiply it or divide it by b. Same as spread. We've talked about this a bunch. Shape. That's not a common thing for us to work with. I didn't mention it on the previous slides, but it was on there. No change. For measure of center, add or subtract a, and then here's that big one. I'll put it in red. Measure of center if you're adding or subtracting. No change. Alright, so this is going to have a couple things going on with it. It's going to have some transformations, multiple, and it's going to have a probability calculation. Notice no probability distribution. Okay? And really, quite honestly, if we are asked to take a distribution and calculate a probability, really, I mean, other than just like if we had the table, we could add up certain probabilities, which isn't too difficult to do, but if we don't have the table, it's got to be a normal CDF if you really think about it. We haven't seen anything else to calculate a probability from a distribution. Okay? Look, because again, we first covered that in Chapter 2, but look at problems very closely in Chapter 6. You'll see them come back, right? But we're not doing normal distributions all the time, so they can be kind of sneaky. One thing we're going to need for our new variable y is a mean and a standard deviation. That's what we need to do. This one breaks down the 4-step. Just, again, I'm kind of building our way there. We don't really do it until Chapter 8. Okay? But this is like state, plan, do, conclude. You know, up here we're kind of working in the plan step to kind of get it together. Okay, what we're going to do. Our plan is that we're going to do a normal CDF, but we need a mean and standard deviation. For the original test scores, it's 17.2 and 3.8. Now, don't you dare go to normal CDF and use those numbers, because the instructor of the course transformed these numbers. The first thing that was done is each score was multiplied by 4. Well, that would be like B is 4. And then he added 10. So for mean, thinking back to what we just saw, I got to do both, because means will be affected by both. Multiply by 4 and add 10. The mean that I want to use is 78.8. And who knows what's going on as far as like, this could be like converting the scores to a percentage and it was curved or something like that. The problem doesn't tell us, but that could be the reason for these transformations. Here's the tricky one. Multiply sigma by 4, but do not add 10. And that is like the mistake I worry about the most. because it's tempting to do. You see, oh, multiply by 4 and add 10. Do it to both of these. Don't add to the standard deviation. All right, then we state what we're doing. Actually, I was kind of doing some prep work there. There you can see we've stated what we're going to calculate. The plan step, calculating those things was kind of like the plan step, but that's all right. This is really going to go into the do step, where I'm actually going to do the calculation. Nice normal curve, centered at 78.8. Sigma is 15.2. And we're like right here. The question that we're addressing is actually what proportion of students would have a 90 or higher. Okay, 90 or higher. You'd go normal CDF, 0.23. So the probability of randomly selected student gets a score of at least a 90 is about 0.23 or 23%.